Welcome to the PC Perspective Podcast. This is episode 202 on May 16th, 2012. I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Alan Malventano.
And Ryan's taken the night off because he is flying between various conferences and madly posting stuff for us to talk about as he's waiting. But as we haven't had a call in a long time, I'm not sure you guys remember the phone number anymore, but it's 1-888-38 PC per. It's still there. I don't know if Ryan's ever checked the voicemails in a long time, but seriously, if we can get enough voicemails, there's got to be something good enough to post up here. Or you can always get a hold of us at podcast@pcper.com and catch all our old episodes at pcper.com/podcast. It's been a busy week this week. In fact, so busy it almost feels like we would have talked about the GTX 670 release last podcast, but unfortunately missed it by about a day, as the video viewers might know, because Ryan was sort of showing off a bit of the card, but he didn't get a chance to talk about it because the NDA wasn't up until after the show, unfortunately. But the good news is that we do now know about the $400 challenger to the HD 7950, and NVIDIA's really hit the ball out of the park with this one, right, Josh?
Yes. This card for $399 pretty much, well, it smokes 7950, and it is very competitive with the standard clock 7970. In fact, it is so good it nips at the heels of the GTX 680, which is $100 more expensive. And one of the things that Ryan talked about extensively was you really don't get all that much more performance by going with the higher end card for that kind of money. So it's it's a good performer. It's got one SMX unit disabled. So it's got what's 1536 minus 192. Anyway, 1300 and some odd.
1344.
1344. It's got those stream units, so it is still 2.5 times more powerful than the GTX 580. It still eclipses that particular number. It still has, what's interesting is it still has the same 256-bit memory bus, and it runs at the same speed, so you have the same kind of bandwidth as you do with the GTX 680. So they didn't cut that back as compared to most other like the HD 7950. It's a slower memory clock on that. Excuse me. So far, it's still been fairly available. I know that on Newegg, I think we're down to about 2 SKUs that are still available. I mean, it first came out, there were about 12 to 13. And so far, it's looking a little bit better than the GTX 680. Now, they've probably been stockpiling these chips quite a bit since the original release. And these were ones that may not have made the cut for a full GTX 680, so they're being used here. So it just kind of, stand to reason that they've been able to stockpile these for a while, and could be one of the reasons why we haven't seen many GTX 680s is that just not many chips were hitting those kind of bins that were needed to have that kind of card. NVIDIA gave the design out to their partners a long time ago. And in fact, the design that NVIDIA had reference is the PCB is actually really, really short. A regular one's about this long, and the 670 is about this long, and Jeremy's probably about anyway. They're just showing that. Yes, they're just showing that some interesting things can be done with the designs. The power circuitry is doing perfectly fine in that kind of form factor. The big blank space behind that PCB, that's just where the fan is going to be sitting. So it doesn't run terribly hot. It still overclocks well. It performs right up there with the GTX 680. And it's got that really nice lime green GeForce GTX and a slightly better power pin placement, in my opinion, than the previous version. And yeah, these things are still available, last that I have seen. What did you guys think of it, Jeremy?
Oh, I'm absolutely in love with this thing. You're looking at sort of the power consumption and heat of the 7950 with the performance of a 7970, more or less. They've really pushed, they've gone completely around from where everyone was complaining, yeah, it's a powerful card, but it's way too power hungry, way too hot. This, is fairly decent because, the 7970 is a pretty toasty card. This one, it gets toasty as well, but at the same time, it's not pulling down quite as much power, which, can mean a lot for some people. And, they added some interesting new features to it, which I am desperately trying to adaptive. It's not coming.
VSync?
Yes, thank you. Adaptive VSync, where you can sort of set target frame rates. So not quite V-synced, but at the same time, it's going to prevent the card from doing the big frame lags or the tearing that you're going to see when you disable it, and at the same time, sort of keeping a really nice average frame rate. And then the turbo speeds are just great because when Ryan was trying to overclock this, essentially what he found is that it was really easy to bump up the base clock rate because it's still sitting underneath the boost clock. So all he did was sort of see the power of the card stay fairly high up and boost a little bit more because it would open up the boost, but for the most part it just meant boom, you're getting huge performance with very, very little effort. So I think definite win for NVIDIA. And the rumor
one of these here, Alan? What?
If only they were easy to buy, right? Or easily stocked in places. Actually, as we say this, there's some 670s in stock at Newegg.
Yep.
Believe it or not.
2 different models.
Yep. MSI and Galaxy.
Galaxy.
Who knows how much stock they have, but, the fact that there is stock. There's still no stock on 680s. I don't think there's any stock on 690s.
Nope.
Even though you might think there's a limited number of people that are willing to plunk down $1,000 on a video card, they're still not in stock. Yeah, it's just hard to get them.
Stock.
I mean, I would probably own a 680 if they were in stock somewhere. I would have probably bought one by now.
Did you ever get that 480 running?
I have no. I didn't put them in because the pesky 680 came out.
You are a slacker extraordinaire.
Sorry.
Sorry.
Upgrades for me involve plumbing. So, I
welcome to your 40s.
Yeah.
Yeah. Right. So I don't. I try to minimize how much plumbing I do.
Some of them you might want to consult a doctor for.
Yes, just a little bit.
Yeah.
Yeah. It thoroughly smokes the GTX 570. If you remember, the GTX 570 only has 1.25 gigabytes of memory. The GTX 670 is the full 2 gigabytes. When you're dealing with resolutions above 1920 by 1080 or 1200, then you start to really eat into the frame buffer. I know, for example, in titles like Skyrim, if you've downloaded the HD texture pack, oftentimes at higher resolutions, you're going to get a little bit more chug, and you're going to get a lot more texture swapping, and it's just not very much fun for people with small frame buffers.
Yeah.
Like Jeremy.
Yeah.
Yeah.
So it's worth the upgrade.
It's
getting the bigger buffer, as Ryan pointed out directly, because a reader of ours asked, is it worth upgrading from a 570 to a 670? Simple answer, oh yeah, very much so. You're looking at not 1 or 2 or a half dozen frames of difference, but 20, 30 of average frames per second increased. And Ryan also wants to dispel a nasty rumor that we've heard, which is
he's got the clap.
He still hasn't dispelled that one effectively yet.
No.
But NVIDIA had said that for the 670, there's not going to be support for Quad SLI. Now, Ryan essentially replied to that saying, with the similarities between the 680 and the 670, is there really any additional QA required to enable Quad for the 670? Seems like a cop-out to me, man. The reply, change in plans, we're offering 4-way SLI. So don't worry if you ever heard those rumors and weren't quite sure about it because, you really wanted to spend $1,600 on graphics cards. You can. You can. You can get Quad SLI for this.
You can do it.
You can do it. You might need an extra power supply, though.
So have you heard any rumors yet of the GTX 660?
No.
Nope. 610,
Apparently
620, and
that's-
630 rebrands.
There
but
sounds like there's going to be a 660 to more adequately go up against AMD at the $300 price point. And from what I've been able to scrape, this looks like it's another partially disabled GK 104. So that'll probably be later this summer, though I haven't had any kind of, official notification. It's just a little something to buzz about in one's ears.
Yeah, bad news, AMD. On the other hand, it hasn't been that great a year for NVIDIA either, because as much as we love these video cards, if no one can buy them, you're not going to see much of a profit. So for the third year in a row, on first quarter, their revenue has been down. They fell to 925 million this quarter from a 1.2 or 002 billion they made 12 months ago. Profit less than half, down to about 60 mil from 137 mil. So this is actually probably really going to scare a lot of investors because this isn't the first or the second. This is the third year in a row that this has happened. Of course, Q1 is not necessarily the best for graphics card sales. Q4 has historically been a much better one. But even when you add that in the end for the fiscal year, they're still falling. And so NVIDIA's really got to hope that, they put out some impressive product that people can buy so they can start making some money back from all the money that they've spent on R&D over the years, because we do really have a solid chip. It's certainly not as available as we'd like to see, but it's a solid chip, and it might see Q2, Q3 look a little bit rosier for NVIDIA. But in the meantime, I don't think stockbrokers are terribly happy with this company.
Yeah, and not only that, but Tegra 2 has not done as well as they were hoping. They were expecting something like $1 billion in 2012, and that was about a year ago they mentioned that. That's where they saw them being, and now it's about 560 million. And so part of that is Tegra 2 has just not selling very well. It's only in a handful of phones, and they're older ones. We've got some of the new Qualcomm chips that are coming out, and like in all the new Samsung Galaxy 3s. So that's another area. Again, they're trying to get rid of the old GTX 500 series, so they were selling them probably at quite a bit lower prices. And yeah, they just have not been able to get a hold of as many GTX 600 series as they wanted to. So yeah, not a great quarter for NVIDIA. It looks like they're still running their business well, so they're not losing money hand over feet. And that's always a positive thing for any kind of company, as far as I'm concerned. They can balance their budget.
Yeah, especially since they're pretty much reduced to being a one-trick pony.
Sorta, yeah.
Yeah.
But Tegra 3 is starting to take off, and there's some good things about that. We just haven't really seen that in many things other than the Asus Transformer Prime.
And even then, not all the models either.
Yep.
Yeah. Well, speaking of NVIDIA hardware that you can't buy, Josh, you want to talk to us about the GK 110? This thing is just insane.
Monster chip.
7.1 billion transistors?
7.1 billion transistors on TSMC's 28 nanometer process. They haven't given a lot of the specifications out as to what the die size of this monster is, how fast it's going to run in terms of clock speed, what kind of TDP we're looking at. Obviously, we're going to be limited to around a 300 watt TDP, and it looks like NVIDIA will probably use every single ounce of that. Brian and I were kind of bantering back and forth and trying to figure out where this would run. It's a 1 teraflop. It's greater than 1 teraflops in double precision applications. Something like 3.6 teraflops in single precision. So it's kind of an interesting mix as compared to a lot of other cards on the market. Usually it's about 1/4 or 1/8 is the double precision kind of hit as compared to single precision. But this thing's a beast. It's probably going to run 600 to 700 megahertz. Again, it'll be 250 to 300 watt TDP, and it's not going to be out until Q4 of this year. And they're detailing it now. They're probably going to get some more information out to the guys actually programming for this. But this is going to be a very high-end compute-only product in the beginning. Now, this may change sometime in the future, but we have absolutely no idea if it will or not. I think that's still up in the air. But so far, this has been just such an amazingly hard processor to create, and it probably is not easy to fabricate at all. And hence, we're releasing it in Q4 rather than right now. So they're kind of waiting for some yields to come around, some of the issues that NVIDIA has had with TSMC. Hopefully that will be taken care of by the time this thing goes into production, because it's going to be 500 to 550 millimeters square, if not a little bit more. I think the reticle limit of TSMC's 28 nanometer process is around 600 millimeters square. And you really don't want to butt up against that very, very closely, because you'll get some really strange looking chips in certain parts of the wafer. So that's kind of a bad thing. What else do we know? It's got 15 SMX units. It's got 2880 CUDA cores. Overall, it hasn't changed a huge amount from the GK104, other than it's got a bunch more double precision units in SMX. As we know, GK104, it only has like, 1/8, 1/24th the amount of double precision as compared to what we'd usually expect. And so they only keep it at that amount for compatibility reasons, but it's not there for speed. And for this one, this is all about high-end computing, double precision, very, very complex type of math. And as we had, Ryan had gone through some of the GTC 2012, and we'll talk about that more. They've added a bunch of features to this that will make it more efficient. It'll do some out-of-order things that it won't rely on the CPU nearly as much. It's just a much more efficient architecture for general type of computing. And even though, and just kind of going on a segue, even though the GK104 is not really optimized for double precision, they are offering these cards essentially what they're going to be GTX 690s, except in Tesla attire, and they're going to be just running massive single precision at some huge amount of teraflops per second, or however you want to do that. It's just so much stuff to go over. It's not even funny. It's a big chip. It's got a lot of features. People in the compute area are very, very, very excited about it. And he's showing you slides right now that we'll go over a little bit more in the later GTC results. But for now, GK110 is the big news coming from NVIDIA. They say it exists. They've detailed it. At least what the functional units are. And there's just a lot of neat things going on under the hood. But it's going to cost you. I wouldn't doubt seeing a single card with one of these chips being in the $6,000 to $10,000 area, and really being pushed in workstation HPC type clusters, those kind of things. And of course, they're probably only going to be able to make that many chips to supply that kind of demand. So yeah, they've got to make up their money somewhere, and that's going to be where they do it.
Yeah. And we could well just see them as supposed to be in cards. The NVIDIA partner with a couple of companies and just put out, rack mounts, slider in. That's an addition to your, an insane addition to your processing power. If you're doing anything that can handle parallel processing. Yeah, this is high-powered computing at its finest, or At least it will be in about a year or so. Now, to head the completely opposite direction from that, Matt Smith just did a review of the Lenovo Idea Center Q180, which is one of the not very much missed, but soon to be probably dead Intel Atom systems. So the 2700 paired with an HD 6450A. Now, the nice thing about this is it's just a tiny little functioning desktop. For certain definitions of the word functioning. It is absolutely minuscule and essentially has an add-on USB optical drive, which can be a Blu-ray if you want. The one that Matt got was a DVD-CD read-write, but it's essentially the same size as the entire system. You'll be able to find it for about $400 or so, and it will literally run anywhere. But being atom-powered, unfortunately, it is not incredibly powerful. We've had a lot of complaints about the Atom over the years, and we just had an article, what we talked about last week, pointing out that as far as general computing goes, Atoms just don't count. They just cannot handle a normal workload. As an HTPC, okay, this makes sense because it is a tiny little thing. It's going to fit anywhere you want it to, and at $400 it's not a huge investment. Problem was that when Matt played back YouTube, most of it was smooth, but it would freeze and bounce at 1080p. At 720 didn't bounce quite as much, but still you don't want to have this and know that this is the best you're ever going to get out of it. Netflix, again, the same thing. iTunes was actually not too bad. He mentioned some VSync problems, which you can see in the videos on his review. But the problem is that while this thing is tiny and cute, it's really hard to say that this is a good solution to sit and watch videos on because it can barely stream live video. So unfortunately, as much as he would have liked to recommend the Q180, he stands by his statement that Atom is dead. And honestly, not missed that much, not even by Intel, who've been kind of neglecting it for a while.
I think a good way to go on home theater PCs nowadays, if you're wanting the whole PC kind of thing, sort of like what this gives you, which is where, you know, you have all the connectivity and keyboard and everything, is that people are moving to Ivy Bridge. So I would say just try to scope out a deal on some K-series Sandy Bridge system that somebody had put together and get it for cheap, you know.
Or even get a little Llano.
Because $400, I mean, you know, if you find someone with a used one they're just trying to get rid of, you might be able to find the system for $400, like a, you know, Sandy Bridge or, you know, or AMD based, anything, you know, with something with decent embedded, you know, integrated GPUs now are they're getting pretty good. If you're doing nothing but video playback, they handle that just fine, even 1080p. You know, where Atom runs into the issue is, even if it's an Ion based thing, the Ion has no problem handling the 1080p on the video side, but the problem is that the Atom CPU itself just doesn't have enough horsepower to handle the stream and everything else involved with it. So that's, you know, that's where you run into silliness, where the, you know, video just not as smooth as it's supposed to be, or drops frames or whatnot. But yeah, I mean, it's anything that I've tested out on a Sandy Bridge based system, even like bottom end, it handles all that just fine. Same goes for the AMD. I mean, AMD's actually been better at that for longer. Right, guys?
Yeah.
Yeah, I hear they even have a new version of it out.
I think Matt talked about it. He's been a busy boy lately.
Yes,
He's been earning his keep from Ryan as compared to me.
Yeah, well, he also got to play with Trinity as opposed to you.
Yes, I did not, but that's perfectly okay because this is the mobile version. I don't do mobile. I have a very non-mobile lifestyle. So
no, you're sedentary.
Well, I wouldn't say sedentary, but I'm non-mobile.
Sedentary?
Know what I'm saying?
Okay. Yeah.
Anyway, the AMD has finally released Trinity, and we know exactly what it is. 384 VLIW4 units that power the GPU, running upwards of 635 megahertz or 650, one of those two numbers. But it promises 50% more overall performance, I think AMD is saying, at the same thermal constraints as the earlier Llano. And testing pretty much says that this is almost correct. It's not nearly as fast as we were hoping, but it is a significant improvement for AMD. Is it significant enough that it overcomes Sandy Bridge, much less Ivy Bridge? No. No. In fact, the graphics portion on these mobile parts, they really match well with what Ivy Bridge now brings to the table. The advantages that AMD have is better driver support, a little bit better compatibility, and when things are a little bit higher quality, AMD takes a bigger lead. Plus, they have seemingly a little bit more robust OpenCL support than what Intel has. AMD has really worked on the power on the pile driver architecture. It's the update of course, Bulldozer. They've improved a lot of things. I think one of the better explanations I've read was at AnandTech, and they really went through the design. And the original Bulldozer, they left things a lot looser than they really wanted to. But to be able to get it out in a timely manner, they didn't have the time to really go through and fix a lot of the issues that the product had. So with Pile Driver, they were able to take the extra time, really tighten up things in terms of transistor count, where they're at, what they're doing. And so we're seeing a major reduction in overall TDP per clock speed or per clock as compared to what Bulldozer was able to offer. Now, we never saw a Bulldozer mobile part, but of course we would not want to see one because it would be really hot and not power efficient as compared to what AMD is now offering with Trinity and Pile Driver. So you can go through some of the articles on there and see that they cut down some of the latencies to the caches. They kind of beefed up the decoders a bit, the prefetcher. They did all kinds of extra stuff to it and include a couple of new features such as FM3 now, or FMA3. If you remember, Intel released FMA3 with Ivy Bridge, or was it Sandy Bridge? But anyway, everybody thought they'd go with FMA4, which is a fused multiply add command, but they in fact went with the 3. It's in ways, from what I've read, not quite as efficient, but when you're Intel, you can push whatever you want. And AMD already supported FMA4, so now they support FMA3. So there's a little bit more compatibility there, and I can't remember the other two features that they've added, but they're basic instructions that make them more compatible now with what Intel has. So yeah, they're going to see these chips coming out pretty soon. We should probably see some models coming out around Computex, and they should be available to the consumer shortly after that. The big deal about this is going to be pricing. AMD is expecting comparable models to be about $200 to $300 cheaper than what Intel has. And while AMD cannot exactly keep up in performance, they believe that they are offering enough in terms of graphics capabilities, overall capabilities, and just plain good enough performance and really good power life, good driver support, good video playback. They've got a couple of new encoding and transcoding schemes with the VCE functionality in Trinity. And so once these things become better supported, then we're going to see a little bit better performance out of AMD when software kind of comes available for it. But where they're really going to be pushing Intel is in terms of price. So you're going to have an Ultrabook from Intel that'll be $800, while AMD's hoping that, like one of HP's Sleek books is going to be around $550 to $599. That is very comparable in terms of overall features as what the more expensive Ultrabook is, based on an Ivy Bridge 22-nanometer product. And when we look at battery performance, AMD is right up there with Intel. And so in very light use, you're looking at about 7.5 to 8 hours of battery performance with the top-end Trinity part. And while you obviously will not be gaming, watching a full-length movie in Blu-ray is not going to kill your battery halfway through. In fact, you can probably get 2.5 to 3 hours with that kind of workload going on. So, AMD is really caught up in a lot of ways. Sure, they haven't overcome the performance difference. The graphics are still slightly better, and it's just it's a better overall product than what we have seen recently from AMD. What are you guys' thoughts?
Well, one of the complaints that I saw from a lot of people was the A10. Well, first off, that it's an A10 because, well, it used to be an A8, A10. You didn't change the core count, so couldn't you just pick a higher model number? But the 4600M that went out is actually the only Trinity piece that is going to have the 7660G for the graphics. The next step up, or sorry, the next step down is going to have about two-thirds of the cores of this high-end part. So you're actually going to be looking at a lot of them performing slower than what we've seen today with this notebook, which was better than the HD 4000 from Intel, but not by a huge margin. So if you're going to start seeing all of a sudden AMD reducing the count on the cores, presumably reducing the frequency as well, all of a sudden Intels are going to be providing relatively the same graphics, maybe a little bit poorer. And really the only thing that's going to be separating them at that point is price, because if you want any sort of general computing, you're obviously going to go with Ivy Bridge. So we got to hope that, somehow they can crank, maybe lower the cores, but crank up the maximum clock on some of the later models so that we can get a little bit more oomph out of it. Because the other thing we'd like to see is some of these parts are going down to 17 watt TDP, which spells very tiny device which lasts forever. As we're seeing it, he was getting 7 hours plus on the battery eater readers test and just over an hour and a half on the battery eater standard, which, is not bad. It's not perhaps as good as some of the previous
TDP part.
Yeah, and that's a 35 watt TDP. So you cut that in half, and you're running a lower frequency on the graphics core and doing a little bit sucking down from less cores. You're going to see some seriously long battery life off of this. Performance might not be brilliant, but it'll probably give you all-day computing without any problems whatsoever.
And alternatively, that might be a good chip to find its way into that same kind of box as that Lenovo that we just talked about. A little set-top, low-power box just designed to stream all your video and that sort of thing. It looks like it'd be perfect for that.
A little bit more expensive than what Atom or Brazos will do, but certainly will give you a smoother type of experience.
Yeah, you certainly will. And it's good to see, because we've been waiting for Trinity for, it seems like, a very long time. And we've been waiting for a good implementation of Bulldozer for a shorter time, but perhaps a more painful time.
Perhaps.
Yeah. On the other end, if you go back to Sandy Bridge E, Ryan just got a DV Nation Ramrod PC shoved in his doorway.
Team Ramrod.
Yeah. Coming through your doorway. And so this is, not one that we've really seen before. I'm not familiar with DV Nation. I'm not sure that anyone else here has heard of them before.
No.
But they can build a mean PC. It's sitting in an Antec 300-2 with an i7-3820 overclocked to 4.4 gigahertz, 64 gigs DDR3 1600 from G.Skill, 6994 gigabyte, two Momentus XT750 hybrids and RAID 0 for your storage, Revo Drive 3X2 480 gigabyte PCIe SSD for the really fast stuff, RAM cache on board, an extra 8 gigs on the PCI SSD and 8 gigs on the Momentus, just cause, and a RAM disk of 42 gigs of ROMX Primo rated at 8,000 megabytes a second. It only costs you $5,400, but watching the reviews of this is going to be quite interesting.
How in the heck did they get a hold of a 6990? That's what I want to know. I haven't seen one of those for sale for at least a year.
That's why. They bought
those guys, they probably have some. Their DV Nation is a a distributor. They're a distributor for some solid state stuff.
Okay.
I think they're the only U.S. distributor for PhotoFast. So
Well,
all
that
those
explains the
PhotoFast,
hybrid drive, the cache
yeah,
drive, and the PCIe SSD.
yeah, they've done a lot of storage stuff over the years.
Yeah. There's another name in storage that has been doing things for a lot of years, but we haven't heard of before. Well, or if we've heard of them, it's because we owned Apple's, which is OWC. And they just put out a Mercury Excelsior that caught both my eye and Al's, because it's an upgradable PCI Express SSD.
Yep, and it actually uses that gum stick form factor, the MacBook Air style. Actually, I have one of them here. It's not an OWC drive, but no, the Ultrabook slash MacBook Air style solid state drive. And OWC has been making those upgrade kits for Macs for a while now for MacBook Air and whatnot. Um, and they just, I guess they had a bunch of them lying around and said, hey, probably put two of these in a RAID and then make something pretty decently quick. So they found the key here is that it comes from OWC. So whatever they make will, at a minimum, support Mac. And in the case of this card, also support PC. So they used, I believe it's like one of the smaller LSI RAID chips, I think, on this guy.
Yeah.
I think so. Yeah. Just a simple LSI RAID chip sitting under a heatsink on a little half-height PCB. And then they have two of these gum stick style solid state drives in there. And it basically is just a RAID 0. So it takes both of them, puts them together, ties it on the PCI Express bus. From the looks of it, it pushes about 750 meg per second sequentials. The random access isn't super. I mean, you can actually get similar or even better 4K random access type numbers from a good SATA 6 gigabit SSD, like one of the newer ones. But the key here is that this is, some people don't have that extra SATA port, or they want something that's PCI Express just for whatever, for their configuration, for who knows what, right? Using all your SATA ports for a huge array of hard disks for, secondary storage, and now there's nothing left for the OS. You get one of these, put it on there. It is a little pricey though, from the looks of it, right? Let's see.
It is OWC.
Yeah. Well,
It
the
is
ones
OWC.
they go in,
Yeah.
yeah,
Let's see, what is it?
360 for 120.
Yeah. So it's about $2 a gig ish.
Compared to a SandForce 2 base drive that's 120 gigs for $114 that you could buy today.
Yep.
Right. Yeah.
On the other hand, you can upgrade it.
True.
Pull out the
And
gum sticks, put in new ones.
Well, but here's the flip side to that, Jeremy. Yes, you can upgrade it, but how much is it going to cost for the upgrade parts, right? Because you're essentially buying two MacBook Air style solid state drives. Maybe down the road. Now realize the same kind of form factor is in like the Asus ZenBooks and a lot of the other newer Ultrabook style devices out there. So there's a chance the prices are going to come down. You're going to get more distributors, that sort of thing. So it would be possible to get one of these and then sort of cheat the system by using non-OWC parts. Wouldn't that be sneaky? Because it's basically just an adapter to connect you to two of those drives. The sizes have to match, though. I'm fairly certain that no matter how you slice this one, you're going to have two of the same. So you can't just
I would assume so, yeah.
Yeah, you can't just be like, I'll do I'll make this one a 480 and I'll keep the 240 and for a little while. No, it's not going to work. But yeah, I mean, it's yet another solid state storage device thing out there. And yes, it is bootable. It uses a regular LSI RAID chip. They didn't strip the boot ROM out of it. It would act no differently than an LSI based RAID solution connected to two of these SSDs. The actual connection to them is the same kind of deal. It's just that the connector is physically different, but it's still serial ATA 6 gigabit. So just physically different, arranged differently on the board, if you will. But yeah, it's the more solid state stuff that comes out, the better, because as we've seen, more and more of it comes out, and then it just keeps getting cheaper and cheaper and breaking $1 per gig. I would like to see some of these prices break $1 per gig on the after this and that rebate prices. Like, I'd like to see somebody come out and just be like, bam, dollar a gig, MSRP, and then let the price go down from there. That would be nice, but
That's a price
hasn't
where I'd
happened.
like to see.
Yeah, needs to get
Definitely.
there.
Well, as we threatened earlier, we are going to return back to NVIDIA because at the GPU Technology Conference, they're just having a great time. We've talked about the hardware, and if you're wondering, it's not going to be in a graphics card anytime soon, but what exactly could this do for me? Well, they're actually looking at something called grid cloud gaming computing, where they're
That stands
essentially
for gaming-related immunodeficiency, right?
yes, and this way they can spread it quicker.
Yes.
Oh, they can spread it so fast. But they're looking at virtualizing GPUs, which, if anyone has been playing with virtualization, knows is a right royal pain. These guys are looking at pairing, up to 4 GPUs and an ungodly amount of SM units on it onto one card, and they're going to be able to stream high definition video from that from a server that's running these cards to anywhere. So they'll be sending, much like we've run into with OnLive, that they will, instead of sending you the actual processed bits, it's an H.264 stream. In this case, what they're doing is taking the compression down insanely and reducing the size of the game pipeline. So what we've been seeing in gaming with gaming on the cloud with OnLive and other services is huge latencies. Almost upwards of 300 milliseconds, which is beyond annoying and essentially onto unplayable. With a console, you're sort of looking at the same thing, not quite as bad as online, but what NVIDIA figures is that they can provide console-level gaming quality to any device whatsoever that can connect to one of these servers over the cloud. It really looks like Kepler's going to be put to its workload because with these frame buffers, just being boom, encoded, sent to you, and these guys they're trying to say they'll get it within about 100, 150, which is decent. It's not going to be quite as good as you're used to on a PC, but NVIDIA's been very careful to say this is console level gaming quality. They'd really like to be able to say that, you should still buy our high-end GPUs for your computer if you want that experience. But if you just really want to be able to play anything on any device or stream any high-definition video to any device, they're thinking that if you sign up for this grid service, they're going to be able to provide it to you. Do you think that they're actually going to manage to be able to beat OnLive at their own game, Josh? Or
Well,
do
I
you
mean,
think that...
Gaikai's been around for quite a few years now.
Yeah.
2 or 3 years. They've been working on technology, and they seem to be doing okay. I think that they've actually, got quite a few Facebook's games on there, and that's essentially how they serve it, just with, kind of lower end hardware that is, not these new GeForce type, cloud graphics cards. So, yeah, they're kind of trying to. I mean, they were showing these guys playing, Hawken, which is that multiplayer first-person shooter mech game, or first mech shooter game. I don't know, whatever you want to call it. And they're playing it on an iPad, and they're also playing it on a TV. All they had was a control attached to the TV, and the guy was just using the touchscreen on the iPad, and it looked just as good as if on a PC. Well, at least, almost as good, probably. And I was running at decent frames, and it didn't seem like I think that where they had the GTC at, the Gaikai server. Am I pronouncing that right?
I think so.
Gaikai. Anyway, was only 5 milliseconds away in terms of ping or delay. So stuff was happening very, very, very quickly. And the company has set up a lot of data centers all around the world. They serve something like 88 countries. And they say that latency is just not going to be an issue for the vast majority of their customers. And of course, they're doing these Facebook games that latency is not as big of a deal, but they're still making money, and they're putting in the infrastructure. And this is essentially their dream, is to be able to offer these services to people. You can play whatever game you want. You don't have to have a console. You don't have to have a high-end gaming machine. You just, pay them X amount of bucks a month, choose what titles you want to do. Their business model is going to be interesting to go through. But, the chances for them being successful with a casual gaming crowd is pretty decent. They've already got a foothold in there. They're partnering with NVIDIA. And so, the upside of this looks decent. And, we could possibly, maybe this will be a gateway drug for people to become hardcore PC gamers again. They'll see something on their TV, go and play it on the PC, and they're like, hey, I can see the differences here. I can feel how much faster this is here, because there is going to be latency no matter what. So this, it could be a good thing, and whatever's good for the game industry is going to be good for us. Well, for the most part, unless you're EA. And then you just don't care what other people think.
No.
The only thing I didn't like looking at those numbers was that it's not that they skewed it, but they sort of, I don't know. I didn't like one of their assumptions. They made an assumption that your typical gaming, like your typical display lag is 66 milliseconds, which is like 5 or 6 full frames of lag. It's, it's up there. It's like close to 5 frames of lag. And that's not realistic for anybody with any kind of a decent display, any kind of a decent LCD.
A decent LCD, but that's what they're aiming at is television.
Right.
Yeah, they're aiming for 30 frames a second.
But the difference in lag on that chart, that difference in delay looks much less significant when you make the display lag that big, right? That's the only thing that sort of rubbed me the wrong way about it. And yeah, you're right. Casual gaming stuff where you don't mind waiting like up to 1/8 of a second for whatever you have done to be reflected back on the screen. Sure. Casual gaming type stuff, I guess Facebook style games and third person kind of things, like over the top kind of games, real time strategy, that sort of thing. You could probably do all that on there just fine. But as soon as you get into that realm of, first person ish sort of stuff or driving, like high speed kind of driving game. Just an example, there was like back, way back when original Xbox, I had picked up some cheap, wireless remote for it, and for some reason the remote had some lag to it, and it was really not even like 1/8 of a second, but there definitely was an input lag. There was a delay in getting that signal to the set, right? And in that case, I didn't even have display lag. I just had lag getting the input into the system, which is basically going to be the same effect. And it was like the same game was like almost unplayable. Like whatever that rally game is that I was playing back then. It was just, I was doing horrible all of a sudden. I was like, what's wrong with this? And I just tried, briefly switch back to the wired controller. Night and day difference, right? So it depends on what the game is, right? But like Josh was saying, yeah, the casual gaming stuff, casual gaming tends to not be as much like people just sit on the couch doing whatever. It's not necessarily going to be like first person shooters or Twitch kind of games, right?
And they still don't want you to buy their GPU for the Twitch games. This is just for when you're not sitting in front of the computer.
Right, exactly. Yeah, and it could do really well. Yeah. I think the fact that they have the architecture and they're you're getting rid of that step of having to grab the frame and then recompress it and do all that stuff, because that's what OnLive has to do, as far as I understand, right? They still have to tack that extra step on. So they're, at a minimum, going to add another frame worth of delay onto their process, whatever those bits have to do on the server side. In this case, the frame buffer is just, it's getting compressed as it's being created, basically. So yeah, that step's just gone. Just that by itself makes it, that much closer to something that you can do, right?
Yes. Other technologies they talked about is true virtualization for the GPU. Now, something that they showed was a guy working on his desktop running Maya, and you think, well, he's just doing a remote desktop. Well, not quite, because when you do remote desktop, it's mostly software driven by the CPU. And so it's not as well, it can be as crisp and as clean, but you're going to have some issues in terms of performance. And in this case, they're using things like Maya, I think some kind of Lightwave or some kind of compositing application, which is GPU accelerated. And because of the way it works, and they're able to virtualize the GPU, they had much better performance. He was able to do things again on his iPad that you just simply would not be able to do any other way. And more needs to be talked about to really get into some of the bones of the matter, because some of it was kind of glossed over in GTC, but they are, they are working on true virtualization of the GPU in conjunction with the CPU, and that's, yeah, it's just, I mean, they're able to also easily chop up the GPU. And they showed this one thing. This one single rack was powering like 100 screens, and they did the same thing. You virtualized the CPUs, and the GPUs again were virtualized. So there's only an X amount of GPUs doing things, but you could stream. They had like 100 videos streaming out of there at H.264 type quality. And if you watch the video, it is interesting. And the power and the way that they're able to, get up this, chop up the work was impressive, because they were talking about, in the GPU, you have instructions going into the shader cores, and they are, essentially tagged for one of the VMs. And right behind it is another instruction going into these SMXs that's tagged to another virtual machine. So it's not just, hey, we're going to render a frame for this, VM. It's like, it's very, very granular in how that they are, working through these instructions. So it's neat technology, and I think we're really only in the infancy of what you can do here.
Well, and they've been smart about it too, because their hypervisor, they've been programming from the straight beginning to be compatible with Citrix and a lot of the other virtualization clients that people are used to using. So it's not like you're going to have to completely redo everything from scratch. This is something you can add on to a virtual machine cluster and all of a sudden be able to offer, a completely different way of doing remote computing. Because if remote desktop or even just working on a virtual machine, you do notice odd things. And the other nice thing is that user selectable machines means that not only is it tied in directly with the virtualization client that you're used to, you can now pick and choose how much power you're going to be sending to each and every one of your devices by device. So someone who's hooking up with an iPad is probably not going to end up with quite the same GPU power being offered to it as somebody who is walked in with whatever their desktop is and want to run that way. It's going to be interesting. So you're going to be able to deal with the guys who are just on a 9-inch screen and the guys that are on a 6 LCD display. So it looks like NVIDIA's spreading out a lot of what we want. On the other hand, they're still rebranding cards. They put out the 630, 620, and 610 this week, and you've seen them before. Say hello to GF108, GF119, and GK107 yet again. In fact, one of them is actually a rebranded 400 series. Kind of impressive, but on the other hand, if you're looking for multi-monitor support at workstation level, and you want it to be able to fit in a low-profile case, you want to be able to passively cool it, Zotac has a couple of interesting little cards for you with not very much improvement from the last series, unfortunately. But that'll about wrap it up for the news stories this week. And it's on to the hardware software picks of the week, of which Ryan, of course, being not here, Probably wish there was,
His pick
high
is
bandwidth.
Delta frequent flyer miles.
Yes. Obviously not Virgin, because I think he would have got Wi-Fi on that, and we could have tried to stream him from 10,000 feet in the air or something.
35,000, yeah.
Yeah. Or a trip to space.
You wishes. But on our chat this week, Tim mentioned that, Ken originally mentioned it, and Tim posted that the Runcore SSD with physical data destruction, because there's nothing that could possibly go wrong with giving somebody a red button with which you can actually set the NAND chips on an SSD aflame. There's no way anything bad could go about that. And while I've been sort of looking, I can't really tell if there's actually a capacitor on board this, or if whatever it is that they've got for the button that plugs into the PC or the SATA power and data is actually what's sending the charge through, in which case not only can you destroy the Invincible. Oh, jump to 220, Burke.
Yeah, it needs to have the system power has to be on for this to happen.
Yes,
and I didn't see
will
any
it work with
capacitors on
any
the board.
SSD?
Flare somehow.
Oh, no.
Power's
Well,
got to
okay.
be on. You push the button, the magnesium flare goes off, and you fix right.
No, what it looks like they're doing is they're just overriding the regulator. Like when you hit that button, it just does not regulate anymore, and it takes the full 5 volts and just blasts it at those chips, which
She's
pretty much
standing back.
overheats them in
She's
short
standing-
order.
Oh yeah, she's scared.
Yeah, she's backing up. This SSD will self-destruct, and then it actually does. The smoke actually
smoke.
comes out of the thing, right?
The
Yeah,
magic
and then
smoke.
and then they crack it open. But I actually do have a couple of reservations about this because the system has to be up and running. So if your system's off and somebody's barging through the door, oh my God, I need to destroy
Child
my whatever.
pornography.
Yeah, it's like, oh no, so you actually have to go and turn the computer on, in order to. It's like I need to wipe all my stuff. Quick, turn it on.
Just
What?
give me a second here.
Yeah, hold on. Let me turn my computers on so I can hit the button. It's like, Not only that, but if the system is up and running, and say this is your OS drive, keep in mind this does not absolve you of everything. Like if a good forensic person can actually do what's called a live image of the system RAM. So if you had bad stuff open, it's in your RAM until you shut the system off. So that's sort of the other detractor to the fact that the system has to be running for this, right? Because if you need to have some like panic situation thing, ability, whatever, you need more than just this. But this is definitely a key factor in it, right?
That's awesome.
So you can
It
hold
melts
somebody's
the
hot
frickin'
data.
chips.
Yeah.
Yeah, it's just great. I just, picture holding somebody's SSD hostage. Give me money or the chips get it.
I've got a dead man switch. It's attached to your SSD. Insane.
Josh, what's your pick for this week?
You know what? Since NVIDIA doesn't have an answer yet at this price range, I've been working on the XFX HD 7950 Double D. Yes, you read that
Ooh.
correctly, or at least heard it. The Double D. And
That goes with the
for
Ramrod
around
system.
$250, it's still a really fast card. It's a new generation. Doesn't pull a lot of power. You can overclock it up to, I think, 1050 is about the maximum you can get due to AMD has kind of locked things down. Get a free game with it, even though I think it's, Dirt 2? Even though they say 2 Dirt game coupons. Unless, of course, the 2 Dirt game might be Dirt 3 and Dirt Showdown. You'll have to buy the damn thing and then see which ones you get. But anyway, $270 for a 2 gig card that runs about as fast as the last generation HD 6970. Runs cooler, quieter, has a few more bells and whistles, and is a nice card for the price.
And my pick.
Much
gonna
less
go a
destructive
little-
than mine.
Yeah, I'm going to go a little lower tech than Jeremy. Actually, Jeremy, there's another part to that drive. There's 2 buttons, not just one, right?
Oh,
The red
yes, there is
button-
an intelligent erase, but bad.
Yeah, so the red button is the, oh my God, make this thing break right now, right? But there's like a green or a blue or something. There's another color button that basically just tells the drive to do a secure erase. So it does the same thing as if you had prompted through software for the drive to
Well,
do a
it
secure erase.
deinitializes it.
Yeah. which actually that will take it like, depending on the drive size and how the flash memory is set up, and it's going to take it like 30 seconds to a minute to do. So just keep that in mind. But that's the other thing I noticed. There's not really any kind of feedback. I mean, you hit that button and it's like, okay, you don't get a poof of smoke like you do when you hit the red button, right? So you're not really absolutely sure when it's done doing what it's trying to do. So who knows? I guess you hit the one button, and then if the door breaks down within 20 seconds, then you just hit the other one and the whole thing falls up. So if you don't want to do that stuff, it is possible to protect your data from people with TrueCrypt, and which is just a software version of encrypting your entire drive, right? And a lot of people have complained that it's like, hey, it's doesn't work on this, doesn't work on that, and it's bad for an SSD. And so as of where is it? I'm reading an article as of 7.0A version of TrueCrypt, which is actually like a couple of years old now. It did support SSD trim commands, which I did not know. Fortunate for that. So trim is just where the operating system passes on information to the solid state drive to let it know, hey, I deleted that stuff. I don't need that stuff where it's at anymore. I don't need those files, those LBAs, those sectors allocated anymore. Apparently, it's capable of passing trim, and not only that, but it uses CPU-based, just like the extra SSE2 or SSE3 instructions on the CPU, and it uses that as a means to accelerate the encryption and the decryption. So new versions of TrueCrypt can easily do like over a gigabyte per second throughput as far as the encryption/decryption engine. So that's still faster than pretty much anything you're going to see for storage in your system, right? Especially with even more modern processors that are even faster than that. So this is a very easy way to have your entire operating system drive protected. Again, same thing applies as I said before, though. It is possible if somebody gets a hold of your machine while it's still running, or if you have a laptop that's just sitting in standby, there are some tricks you can do, and you can get an image of that memory, the actual system RAM, and the password will have to exist somewhere in RAM in order for the whole thing to work, right? So keep that in mind, right? If you're gonna be so overprotective about your hard drive as to do full disk encryption, or if you're gonna go that far, then don't sell yourself short. You have to take the extra step, and for that it'd have to be like never use standby for your laptop, right? Always shut it down all the way. Always make sure it powers down all the way. That sort of thing. RAM can still hold data for a short time after the system powers down, but it's not very long. Especially if you still have it's still in your physical possession for a few minutes after you've turned it off. It's probably all gone by then. That's not coming back. But just food for thought.
Not that we're paranoid or anything, or have anything to hide whatsoever.
No. Where's my damn button?
Yeah, Josh wants the button. By the way, that is
Can I
physical
use my lighter?
only. That drive, that button is a physical only thing, right? It's outside the drive. It's not a software controlled by any means thing. So if it was, I would immediately look into writing a really nasty virus for anybody that had one of those drives.
Yeah, Wi-Fi enabled. Poof, 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 poof.
Yeah. All your
Well, on that
SSD
note-
belong to us.
Yes. They're hostage. The bits are mine. Well, I think with that, we're going to wrap up this week's episode of the PC Perspective podcast. So leave us some voicemails, 1-888-38-PC-PER. I can't guarantee Ryan will ever listen to them, but on the off chance that he might someday do it, give it a shot. You can also reach us at podcast@pcper.com. Catch all our old episodes at pcper.com/podcast. Look for either Ryan Schrout or PC Per on just about any one of your favorite social media sites, and we're going to be there. But that'll be it for episode 202. With that, I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Alan Malventano.
Thanks for watching and listening.